Hey everybody, this is Alex Merced from alexmercedcoder.com, and what I wanted to do was just make another video on objects and prototypes and functions. So I've kind of done a lot of videos on this topic recently because I've been learning a lot about this recently, um, and just a lot about the intricacies underneath the hood in JavaScript. But I keep feeling the need to go back and do it again to make it clearer because this is a fun topic. So let me get what I'm talking about. So first thing we're gonna do is we're gonna talk about prototypes. So imagine a world. So if you're not very familiar with JavaScript, then I recommend going to my JavaScript playlist and watching sort of all those introductory videos, because you do have to kind of have at least a somewhat appreciation for JavaScript as it is now to appreciate what I'm going to cover. But I'll do my best to make it where you don't need that much of an appreciation for JavaScript to appreciate what I'm going to do now. But once upon a time, before ES6, there were no classes. Okay, so you couldn't create classes. There was no arrow functions. So basically everything revolved around the function syntax. And the reason, so basically, if I wanted to create something like a class, I'd use a function. If I wanted to create a function, I use a function. Okay, so if I wanted to create a function, I would do this. Const myfunc equals function console.log. Hello. Actually, let's make that a string. Okay, and if I wanted to create a class, you had to do this. Const my class, because there was no class keyword. So functions played a dual role as a constructor, as a way to create constructor functions and a way to create traditional functions. So I would do this function this dot name equals, well, actually let's do pass in the parameter name. This dot name equals name. Okay, this dot say name equals function console.log name, or this dot name. Okay, so these look like two functions, but really one is a constructor function and the other one's a traditional function. Okay, so bear with me here, it's all going somewhere. So if I were to call the first function myfunc, I would just call it like that, because it's just the function and it'll do what I tell it to do when I invoke it. Now the other function, because of me using all this keyword, to be able to take advantage of that this keyword, I had to use the new keyword. So I'd be like const alex equals new my class alex. And then I can use their method. So I could be like alex.sayName and invoke that. Okay, and notice, like, you're like, wait a second, this just looks like when I use classes, because it literally is. That's literally what's happening when you use a class. So if I were to use this, run this code, see, first we see the hello, because my func is run as a normal function, and the console.logs hello. But const my class, because I kept using the this keyword, I have to instantiate it. So I do new Alex, or new my class, because that's the name of the function. And that's that. Okay. Cool. And then so now I could actually just use Alex as if I had instantiated a class. Cool. But that was really confusing for people, because in every other programming language, or at least every modern object-oriented programming language, your C++s, your Javas, your Pythons, Go, name it, Swift, Kotlin, they all have classes for this kind of work. Okay, so you always think, hey, if I need to construct an object with sort of set properties and set methods, I use a class. But JavaScript didn't have that. Instead, functions had this weird dual role, which is very confusing. Okay, so it wasn't until ES6 that they say, hey, let's not have functions play this double role. we're going to separate it into two things. Okay? So going forward, functions will be just functions. So I can use this syntax, and it's just a function. It serves no dual role. It only works as a function. Just to show you, if I were to take this function here and turn it into an arrow function, it will no longer work. Okay, so this will no longer work as an arrow function. Only that old function syntax. And the only reason they didn't change the old syntax is because they didn't want to break the old code. So generally when a programming language adds things, they don't usually take out old things. They just build new things on top of it, because there's other people who have software that's built with the old things, and last thing you want to do is break all that code. Okay, so if I were to use this, now if I run the code, I'm going to get an error because I just turned this into an arrow function, and arrow functions cannot be used as object constructors like the old functions. Okay, see, my class is not a constructor. So in modern day JavaScript, you would use this instead. It would be, instead of const my class, it would be class my class. Okay. And basically I had to get rid of this whole function wrapper. And instead, wrap it in a separate curly bracket. And then all of this would have to be in a constructor function. Okay, and the great thing about this is just that it's more obvious. Like, okay, I know it's a constructor because I wrote the word constructor instead of it being implied in the old way. Okay, and you're always better off when things are, you know, clearly defined. So let me just move all this around. Okay, let me save so that way it formats everything. Okay, cool. Okay, so that's the way you would do it now. So functions, when you're using arrow functions in classes, it separates the two things that the old function used to do. Make functions and make classes, or make objects, or make object constructors. So now this code will work again because this was turned into a class, and arrow functions work for functions. So let me run the code again. And see, it works again. Okay, so that's sort of the big change from ES5 to ES6. Instead of having this function that does everything, or a function syntax that has a dual role, you end up with a pure function syntax, arrow functions, which makes that nice because you don't have to worry about this weird underlying object inside of it. And then you have class constructors, which just provides a much more familiar way with creating those kind of constructors for most programmers who are coming from other programming languages. Cool. Okay, but at the end of the day, it's still not quite what's going on in JavaScript, and all of this is still not quite what's happening in other languages. Okay, when you create a class in pretty much any other language, what you're doing is you're creating a blueprint. You're creating instructions saying, hey, whenever you want to create a project, an object of this type, this is what it has, but it doesn't exist yet. JavaScript operates through what's called prototypical inheritance. It's very unique. I think it inherited this from the Scheme programming language, which was partly based on. Okay, so if you don't know the history of it, basically, I always forget the name of the creator. But what happens is that he's told, hey, we need a programming language for Netscape Navigator, the old browser from the 90s. You got 10 days to make this. The guy wanted to make a language based on Scheme, which was sort of a functional list-based language, but he was told, oh, well, everyone's using Java these days because Java's spending all this money on marketing, so also make it like Java. So he kind of borrows ideas from both languages, or borrows ideas from Scheme and borrows syntax from Java, and you have the early days of JavaScript, which, you know, a lot of people weren't necessarily huge fans of those days, but JavaScript's evolved from there. Cool. So that's why JavaScript has such a weird underpinning. So it doesn't, when you are working with objects, you're not necessarily creating objects from a blueprint when you use a class. What you're really doing is creating a prototype object in a sense, okay? And just to show you how prototypes work, because that was another way for you to do object-oriented programming. You could work directly with prototypes, okay? Everything is an object in JavaScript. So like literally, you know, arrays are objects. Okay, so arrays have properties. So I could actually sit there and say all arrays have a property called cheese. So how would I do that? I would go array.prototype. This represents the array prototype. the imaginary sort of original array. Imagine like there's an Adam and Eve of arrays, the first array, and then all other arrays are sort of a copy of that original Adam array. Okay, that's essentially, so I go, this array prototype is the original array object that has the definition of how arrays work, and then I can add properties to that object. So I can be like array.prototype.cheese, and we'll just say equals 5. Okay, so now if I make a new array, const my array equals 1, 2, 3, 4, 5. Now I can do console.log my r dot cheese and watch what happens. 5. It's like, wait a second, I don't see, well, I do see a 5 in there, so let me take out that 5 just to make this a little more clear. Let me run that again. 5. So where's this 5 coming from? There's no 5 in the array. I never assigned 5 to my r, but I did assign a property called cheese to the array prototype, which means all arrays, when they're created, are a copy of that prototype. They're a copy of that object. It's like cloning, okay? So instead of building a house where you take blueprints and you build that house, what we're doing is we're taking a living, breathing object and cloning it, okay? And it's still a little bit different than that, okay? It's slightly different than even cloning. Probably not even the best analogy. It's more like, I heard someone use like the analogy delegate. I'm not a big fan of that one either. But essentially your backup. Okay, so really what's going on here is that since the array prototype is the prototype of my array, okay, this object that exists automatically within JavaScript is the prototype of every array that you create. If I call for this cheese property, it takes a look at my array. And if I were to console log my array, you'll see it has no cheese property. So I'm going to console log it. See, it has no cheese property. Okay, and just to show you that you could add properties to the array after the fact, I'll do this. I'll do my r, because again, arrays are an object like everything else, so you can add properties to it. So if I were to do my array.cheese2 equals 6, watch what happens. So I hit save. See, now my array has the original values 1, 2, 3, 4 that are indexed, and then it has this keyed value cheese2 that equals 6, because that was actually assigned to that specific array. So you notice there is no cheese in my array. So why does this work? Why does this still find out that there's a 5 somewhere? Because the way prototype works is that if the object that has a prototype doesn't have the property, so since my r does not have cheese, it goes and checks out its prototype. And the array prototype does have cheese, and that cheese equals 5. Okay, so that's how prototype works. It's like creating a chain, saying, hey, it's kind of like having a cosigner on a loan. Hey, if I don't have the money, go check out my parents. Okay, you go check out the backup, and it keeps going up the prototype chain, which is the term for the prototype of the prototype, because kids could go on for a while. So let's give you an example. So another way you could have done sort of object-oriented programming in JavaScript is you just create a basic object. Okay, so I'll create, let's say, my const my proto. Okay, and this is just an object, and the object has a property called name. Actually, we won't give, we'll call it a property called name, which is just going to start out as an empty string. Okay, it'll have another property called say name, and say name will be a function. And I want to use the old school function syntax because I'm allowed to use this keyword there. If I were to use the newer arrow functions, can't use this in arrow functions. Okay, no this in arrow functions unless you're working in a class. Okay, so say name function, we're going to console.log my name is this dot name. Okay, so this is my object. This is just sort of my prototype object. Okay, now let's say I wanted to create Alex. Const Alex equals, and then I'm going to use this function object.set prototype of. Again, you never really see this in code because why would you do it this way? And with set prototype of, the way it works is that I say what object I want to set the prototype of. So I'm going to create a new object, so just a new empty object. And I'm going to set it the prototype of my proto. Okay, now watch what happens. So if I were the console.log Alex, it's just an empty object. Because what did I create? An empty object, but it has my proto as a prototype. So what I can do is do alex.sayName, because even though Alex doesn't have a sayName property, its prototype does. Okay, save. So let's run it. Oh, I didn't invoke the function. I've been really bad about that lately. Okay. See? And again, name is currently an empty string. So let's do something else. Alex.name equals Alex. But isn't there already a name property on the prototype? So let's see here. Which one is it going to pull from? The prototype's name or Alex's name now that we've defined one? It pulls from the original one. Because again, this refers to the specific object that's making the call. That's how this works in JavaScript. Okay, it doesn't refer to the where the function exists. So even though the function exists on my proto, it is Alex who's invoking the function. So then any use of the word this going forward is by the object that invoked. Okay, not the object that defined the function. This is why you end up with all that weird this stuff in React. Okay? Because technically your DOM element is invoking the function, even though you define the function in your your component. Okay. So keep that in mind. So who called the function? Alex. So this is always Alex. So this becomes alex.name. And since Alex has a name property, we use that. Before, Alex did not have a name property, so it defaulted to its prototype, which was my proto. Okay. So that was another way you could end up kind of with the same result. I could just sit there and create this sort of template object, literally just create an object and then just say this is the prototype of something. And then I could do it as many times as I wanted. So this literally, when you use inheritance, when you use like, class this extends this, all you're really doing is just, again, creating a prototype chain. So it's literally me doing this. Const Alex Jr. equals object.set prototype of empty object. So we're going to create a new object, except the prototype is now Alex. So it's not looking at my proto as its prototype, it's looking at Alex. Okay? But now watch what happens. So if I were to do Alex Jr. dot name equals well, first actually let me console log Alex Jr. console.log Alex Jr. And then we're going to use that sayName function. sayName. Okay, and let's watch what happens. sayName is not defined. Oh, oops. Alex Jr. dot sayName. Save. So see, the function runs, and again, see, Alex Jr. has no properties, so it has no sayName property. So what it does, it looks at its prototype. And if I were to console log Alex on top of that, console.log Alex. See, Alex has no property, so Alex doesn't have sayName either. So it goes to Alex and says, Alex, do you have sayName? And Alex is like, I don't know. go talk to my proto. And we go to my proto, and my proto, we go, hey, my proto, do you have say name? And you're like, yeah, I do. Here it is. And it uses it. Okay? But again, going forward, anywhere you see the this becomes Alex Jr. dot name, because it's Alex Jr. who invoked the function. That's the object that invoked the function. Again, it's not where the function is defined, but where the function is invoked. So that determines what this is. And that's one of the most mindy bendy things in JavaScript. Once you appreciate that, JavaScript gets a lot easier. Okay, a lot of the weird edge cases have to do with that weird issue. So I mean, this really should be unveiling the curtain on a lot of behaviors in JavaScript. Okay, now you're like, why have I never had to work with any of this? Why have I never had to do really anything with this kind of syntax? Because you have classes and arrow functions now, and classes and arrow functions makes this all much cleaner. Okay, instead of doing all this weird object.set prototype of, we're using functions as a constructor, there's all sorts of weird ways of doing things. They can still be useful in certain situations. Okay, and what if you did want to kind of use an arrow function as a class? You still could. You wouldn't be using a constructor function. You'd be taking advantage of something called closures. So might as well talk about that now too. Okay. So let's give you an example of that. So again, that's prototypes. So again, prototypes literally is just saying, hey, this object over here, you can reference. So if I don't have this property, check out them. And then if they don't have that property, check out their prototype. That's it. Okay, that's essentially what prototypes are. Prototypes is essentially what's underlying the class functionality in JavaScript. And it's why the old school function syntax behaves the way it does, which is why they came out with classes and arrow functions to make that much cleaner and more obvious. Cool. Now, just to show you kind of a fun trick, okay, what you can do with an arrow function, if you wanted to kind of like, if you just really wanted to be fancy and kind of create a class using a arrow function, which is not a constructor, again, but you separated that functionality out of it. So how could I still do it? And you won't have access to the this keyword, but you could. This is how you would do it. Okay, const. Let's say my person equals, and then we do an arrow function. We'll pass in the name of a person. Okay. And this takes advantage of a way that functions work in programming. When a function is invoked, it creates its own little scope. Okay. Anything inside the function lives inside the function. And anything that's inside the function can refer to stuff inside the function. It's like a little walled garden. This is what's referred to as a closure. Okay, or this whole concept here. So in this case, I could just say, hey, we have this variable called name that exists in this function. And what I want to do is I'm going to return how do I want to do this? I'm going to return an array with two functions, just to kind of illustrate the point real simply. Okay, so basically this array is going to have two functions as its two elements in this array. And the first function, okay, what it does is it just console.logs name. Okay, which is weird because, well, you'll see why this is going to be weird. Console.logs name. Okay, and then the second function takes a parameter, we'll say in name2. And all we're going to do is say name equals name2. Okay. Very cool. Again, now we're getting into some really fancy stuff. So if I'm starting to lose you, don't feel bad. We're getting to some real bleeding edge fancy JavaScript right now. Okay. Okay, so basically I've created a function that's going to return me an array of two functions that refer to the parameter I passed in. I'm not 100% sure if that's going to work the way I want it to. The reason is because I think I have a feeling the parameters are constants, but we'll find out in a moment. Okay, or the argument's going to be treated as a constant, but you know, we'll see. Okay, but basically I'm returning these two functions. So basically, if I want to take those two functions out, I can do this. I'll use what's called array destructuring. So what I do is I make an array as the name of my variable, And I'm going to say, hey, the first thing that comes out of the array from the function, I want it to be called say name, because that's what that function does. It says name. And the second thing, I want it to be change name, because that's what it does. It changes the name. And that's going to equal the function. So the function is my person, and we're going to pass in the name Alex as the parameter. Okay? And essentially what happens is that when this array pops out of the function, because the function returns this array, the first element, this function, is going to get put into this variable, and the second function is going to be plopped into this variable. Okay, and this is what's referred to as destructuring, specifically array destructuring. So if you want to get more info on how that works, I have a lot of videos on that. It's one of my favorite features of JavaScript. It makes a lot happen in one line of code. It's very fun. Okay, now just to show you that this works, let's run both functions. So say name, that should console log Alex, because we made the name Alex in this thing. Okay, and then we should be able to change name. We'll change the name to Bob. And then if I say name again, it should say Bob, because we've changed the name variable. Okay, and again, the first time I'm not 100% sure it'll work, because I have a feeling that the name passed in as an argument is a constant, so I may have to adjust. No, it worked. Okay, good. So it's all good. Okay, so, but why is this weird? Why is this cool? Because name doesn't exist out here. Name does not have global scope. Yet, I'm able to pull it and change it from outside of the function. Technically, name only exists within this function, and this function is done. This function happened over here. Yet, I'm still able to play around with this variable that's inside here. How am I able to do that? It's because the functions that are defined inside of the function can play with the variables inside the function. So while name does not have global scope, these two functions that I passed in the array have access to name. They're within the scope of my person. And because of that, they're able to change it. So even though the function got passed out of the function, they still have access. They still kind of have like a tunnel dug into that walled garden. Okay, so theoretically, you could create a whole sort of object with all sorts of variables, and then return a bunch of functions, and create a object-like thing. Now, the only reason in the past you may have wanted to do this is because JavaScript, I think not till this year, will have private properties, which means when you make a class, you can't hide the variables of the class from the rest of the world. Okay, most programming languages, you have private properties, where basically you can say, hey, there's all these functions that use the variables in my class, but if you try to directly change the variables in the class, it'll prevent you from doing so because you named it private. And the reason you would do that is because maybe you only want the variables changed with particular functions, and you don't want other people tinkering around with the variables inside. JavaScript didn't really have a way to do that. Although with this closure thing, you could pretty much do that, because now the only way to access the variables inside my person function is through these functions that I passed out. So that means I can define exactly how you interact with those variables. But this year, 2020, it is going to become part of the JavaScript standard, where in your classes you can put like a hashtag in front of your variable name, and that makes it private. So that'll be a thing. So that would be the only reason I can really think of why you would do this, other than to show off. I mean, I like playing around with it because it's I find the concept of playing with scope interesting, and it kind of opens up all sorts of possibilities for creating all sorts of really interesting ways to access data. I mean, the other situation where this is useful is technically this pattern, this sort of idea is used a lot in React under the hood. So basically, because of this, this is how they make React hooks happen. This is how they make your functional components, your components made out of functions, behave more like class components, because they take advantage of closures to be able to give you access to data in the function. Okay, you can access state, all the kind of stuff that would normally be a property in a class. They have it stored in a function that's stored in some function through closures that you access through like things like useState and all that. So that is a very sort of unique study case of sort of where that becomes useful. And again, that's because they wanted to have a function. They wanted you to be able to use functions in the same way you use classes, and that's technically what I'm doing here. So yeah, so that was 30 minutes. We covered a lot. Hopefully you guys learned some stuff in this, or at least this is probably my best explanation of this particular material. If you followed this and you made it up till now, you definitely now know JavaScript much more deeper and more richly than you did before. And hopefully, it makes you a better programmer. Okay? And it makes it easier for you to read the code of other people, whether the code is old or new. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.